Alright, so today we're going to be taking a look at problem solving. We're going to take a look at the different types of problems that exist, as well as the formal 6-step process of problem solving. So what exactly is a problem? Well, you may be thinking that's a very obvious question, but not necessarily when you think about what a problem is to one person versus what it is to somebody else. Essentially, a problem is a situation that has a goal to be achieved, one or more obstacles to reaching that goal, and no currently known method of solving the problem. At least when you're thinking about the person trying to solve it. So for example, 2 plus 2 isn't a problem for someone like you or me, but for someone in grade 1 that is a significant problem because they don't have the slightest idea of how to do it. And now that we know what a problem is, we need to know how to solve the problem. So in order to solve a problem, you have to follow a set of guidelines to reach the solution. And there are two different types of guidelines that you can have. The first is called an algorithm. An algorithm is a specific sequence of steps to follow for a particular type of problem. And when you follow those specific steps, you will always guarantee a correct result, assuming that you follow those steps properly. So for example, BEDMAS, when doing a math problem, if you follow the steps according to brackets, exponents, division, multiplication, addition, and subtraction, you're always going to get the correct mathematical answer. In the programming world, that would be the similar idea as doing linear programming, or in other words, programming one line of code, one after the other, until you reach the end of the program. The second type of guideline you can use is called a heuristic. It's a general strategy for solving problems and is independent of the type of problem you're trying to solve. So no matter what type of problem you're trying to solve, you can use this method and it will get to you a result. Unfortunately, it's not necessarily guaranteed to provide the successful or correct solution to the problem you're trying to solve. In which case, you would then have to try another heuristic to hopefully get to the successful solution. Examples of heuristics are the rule of thumb, taking an educated guess based on prior knowledge, trial and error, or spam filters. Spam filters are programs that analyze incoming emails in an attempt to intercept unwanted emails. Unfortunately, they don't always work, and important emails may sometimes be identified incorrectly as junk, or unwanted emails may still appear in your inbox. Problems can be broken down into several different categories or types. The first category of problem is called a puzzle. A puzzle usually requires a lucky guess or a sudden insight into the problem in order for you to find the solution. And once you understand what the solution is, it's impossible for you to see it as a problem again. Logic problems require analytical thinking and deduction skills to solve, so you have to slowly work your way through step by step in order to get to the solution. Math problems are problems usually requiring the use of a specific algorithm to solve, and if you follow that algorithm correctly, you will result in a guaranteed correct solution. And applications are the types of problems we're going to be focusing on in this class. These problems involve the use of a specific algorithm to create a computer program to solve the problem. Although there are many different problem-solving processes that exist, the one we're going to be looking at is called the 6-step process, the one that is used by the Global Development Research Center, or GDRC. This is an independent non-profit think tank that solves a variety of problems worldwide. This process implements 6 separate steps: defining the problem, analyzing the causes, developing plans for various solutions, evaluating and selecting from these alternative solutions, implementing the plan, and following up. The first step of the process is defining the problem. This is where you try and figure out what you're trying to solve. You need to ensure that you're solving the actual issue that exists, and not just focusing on a simple side problem or only one portion of the entire issue. The second step is called analyzing the causes. This is where you list the known facts of your current situation. What does the data show to be the major cause of the problem that you're having? And what is a realistic goal for solving this problem? Here you want to analyze the benefits and shortfalls of any current solutions that you already have in place. Why was your product made this way? Why was it designed in the manner that it was currently existing in? Once you've figured out what your problem is and why you're solving it, it's time to start developing plans for a variety of solutions. This is most commonly done by brainstorming, and it's important that you brainstorm in the right manner. When you brainstorm, you need to list all possible ideas to solve the problem. No matter how idiotic that idea might seem, you need to write it down. You don't place any value judgment on any of the suggestions that anybody makes. This is because the creative portion of your brain is separate from the analytical portion of your brain. And by somebody making a really stupid idea, that may lead you to make a jump to the best idea that you never would have gotten otherwise had you not had that stupid idea first. So the more ideas you write down, the better it is. It's very easy to go back later and cross off those very stupid ideas. It takes you very little time. But if it leads you to a phenomenal idea later, then it was well worth the stupid idea that you had. Now that you have a variety of solutions in front of you, it's time to select the best solution to solve your problem. And when you're doing this, you want to make sure that you're providing justification for why you're choosing one alternative over another. In fact, you may even want to come up with a top 3 solution order. In case the first solution doesn't end up working, you now have a follow-up solution to fall back on. Now that we know what we're going to do, it's time to actually go around and do it. So you implement your plan. While you're doing this, you need to make sure you're implementing it properly and effectively. And you also need to be aware of how you're going to evaluate whether or not your solution is actually solving the problem, or is it just masking the symptoms. And finally, we reach the follow-up stage. At this point, you've hopefully fully solved your problem using all the steps through this process. However, you now need to analyze your solution to ensure that it is in fact solving all of the problem. If there are some areas that are incorrect or unsatisfactory, you now need to go back to step 1 and re-implement the entire process over again to fully solve this separate problem.